Okay. Yes. Yes. Ashwani. Any doubt? You just raise your hand.
Sir, EMCT theorem revised.
Can you repeat?
MCT theorem.
Sorry.
Monotone convergence theorem.
Okay, monotone convergence theorem. Okay, we will see.
Yes, sir.
While we see the problem, see, I think today's session, I just wanted to dedicate today's session to completely for solving problems. Okay, so while we solve the problems, we will understand MCT. Okay,
Yes.
yeah. Uh, Let me just share my screen too. Just a second. Yes, I'm not able to share the screen. So is my screen visible? I don't think so. Okay. Okay, I got it. So is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, okay. So I just wanted to toggle between two tabs. Maybe I'll just share my full screen. That would be better, I guess. Yeah. So any prior questions or
Sir,
before I
if
start?
A1 is equal to 2 and AN plus 1 is equal to 0.75 AN plus 1 upon AN cube. Eh,
So okay. If A1 is equals to 2,
Yes, sir. And AN plus 1 is equal to 0.75
huh?
uh, bracket AN plus 1 upon AN cube.
An plus 1 upon an
1.
cube.
Yes, sir.
Okay. So we want to solve this particular problem, is it?
Yes.
Okay. Where did you get this problem? Hello.
Sir,
No.
limit is equal to, yes.
Where did you get the problem? I mean, is it given in one of the activity questions or practice assignments or some
No,
other
sir.
books?
No, sir. Slide question. Lecture. Lecture 8.
Okay, it's a lecture
Yes,
problem.
sir.
Okay.
Yes, sir.
Hmm. Okay. So in recurrence relations or sequences which have a recurrence relation, how do you first check whether it is a convergent sequence or a divergent sequence? Anyone?
We put the
Sir,
value of n
conversion.
equals infinity, and then if we get 0 or if we get infinity, then we decide whether it's convergent or divergent.
Uh, Sorry, I lost you at the start. Can you just repeat what you said again? My question is, how to or maybe simply, when do you say a sequence is convergent?
When it lies in between
When
0
it's
to
a
infinity.
Which thing lies in
finite
between
number.
0 to infinity?
So the an value.
So one says if an lies in between 0 to infinity, in between 0 and infinity, then it is convergent. Okay, any other answers?
So if it is a bounded function,
Bounded function or sequence? I didn't mention function anywhere.
yeah,
Sir,
sir, sequence.
sir, if it is bounded above, I think.
Okay, if an or the sequence an, so this is the representation of the sequence, right? Within the brackets, the nth term, if you show, that is a sequence. So if the sequence an is bounded and specifically upper bounded, then it is convergent. Okay, any other answers?
So when n tends to infinity
Sir,
and
when
the sequence tends to a finite limit.
Then an tends to some
Finite limit.
k, where
Yes.
k is finite. Okay. So any other intuitions or understandings about the sequence and its convergence?
and I think just to argue,
Hmm.
if a sequence is not divergent
Hmm.
and um, it has a limit, right? Because it cannot be sort of oscillating. So firstly, it should not be divergent, and there
Okay.
should be a limit, prescribed. I hope so.
Sequences which are not divergent and oscillating,
Not
Sir,
oscillating
and not oscillating.
or has a limit defined.
Oh, what? Oh, that is what? What do you mean by limit defined?
sir, if it is a monotonic function and it is bounded.
Okay. Let me just keep this. Okay. So see, these many different
Sir,
understandings are, yeah.
when the limit tends to 0, sir.
When the limit tends to 0, then only it is a convergent sequence.
Yes, sir.
When the limit of the sequence an is 0, then an is convergent. Okay, so I got many things here. Let me talk about these 5 things first. Okay. So if, okay, let me just say whether that is correct or not. First of all, so this is wrong. Okay, and this is also wrong. So in some sense, this is partially correct, but not not only the sequences which are upper bounded, they are not called convergent sequences. So maybe partial, maybe small tick. Okay, and this, when n tends to infinity, then an tends to some k. K is finite. This is current. sequences which are not divergent and not oscillating. And I think once we define the convergent sequence, then we talk about the divergent sequences. So you are coming from the vice versa, which this is also not a proper way to say a sequence is convergent. And this is definitely wrong. Okay. So why the first one is incorrect is, let me define what is a convergent sequence, then you will understand. So anything can be a sequence, right? An ordered infinite numbers put placing in one place is a sequence. So you just order the numbers starting from the first number, followed by second, followed by third, fourth, and so on till infinite will form a sequences. And within that sequences, we are classifying some set of sequences as convergent sequences, and some are not convergent, which are called as divergent. And there are few sequences which are not even divergent nor convergent. Okay, so this is the classification we do for sequences. So out of all possible sequences, these are the three main classifications we have, and out of which the very first class is convergent sequences. So what kind of sequence I call convergent is, as I specially mentioned, every sequences will be like this: A1, A2. So these are all real numbers which are lined in order, and so on. There will be the nth real number in this sequence, and so on. This goes to infinite. And see, sequences which has a limit value or which has a finite limit value are called convergent sequences. Very simple. Not every sequence will have a limit value, right? So now, what is this limit value? When do I say sequence has a limit or not? So this is the mathematical representation of this limit value. When the limit, or when n tends to infinite, what is happening to my nth term? Okay, that means what happens to my last numbers in my sequence, very last numbers. So if those numbers are coming to an unique value, so I mentioned a word called unique. If it is going to some L or maybe small l. Okay.
Unique means, sir?
Unique means single value, only one value.
Fine.
Okay. So if I say as n tends to infinite, my last real numbers in my sequences are all being equal to some single value, unique value L. Then I say the limit of this sequence exists, and that is equal to L. Okay, and this L need to be finite. Finite in the sense any real value between minus infinite to plus infinite. So excluding that minus infinity and plus infinity, any real value on the number line. Okay, it can be 0, it can be 1, it can be 2, L can be anything. So it is represented like this. L belongs to minus infinite to plus infinite. Or simply L belongs to any real value. Okay, this is the notation for set of all real values, real numbers. Okay, so this is, so if my sequence,
Sir,
if I
please repeat, sir.
if I have my nth term in the sequence, and if I let n to be infinite, if I am getting a single unique value to this particular limit, and that value is a real number, then I say my sequence, this sequence A1 to AN2 and so on infinite sequence, is a convergent sequence. Okay. I will give you an example here. So the very standard example which is well known to everyone is 1 by n. I am not taking that. A slight extension to that 1 by n, 1 plus 1 by n. So if I represent this 1 plus 1 by n within the brackets, the third brackets, what does this mean is, so this is a sequence, this represents a sequence where my nth term is 1 plus 1 by n. So that means my first term means n is equals to 1 is the first term. Okay. So the first term will be 1 plus 1 by 1, which is 2. Okay. So the second term, when n is equals to 2 is the second term. I should have written it the other way. So second term in the sequence is, you should put n is equals to 2. You will be getting 1 plus 1 by 2 is 3 by 2. Okay. And similarly, the third term, fourth term, and so on. This goes to infinite. This n starts from 1, 2, 3, and so on till infinite. And as it goes to infinite, so at maybe 100th term, 100th term is n is equals to 100, and this is 1 plus 1 by 100, which is somewhat 101 by 100. Okay. So similarly, as I keep on moving forward in the sequence, something like this term, okay, I have to substitute n is equals to 6 zeros, and I am going to get my 10 lakh term in the sequence, or the 1 millionth term in the sequence will be 1,000,001 divided by 1 million. So you see, you observe where this is going slowly. It started from 2, and this is 1.5, and this is 1.01, and this is 1.00001. So if I talk about some 1 billionth term, it will be somewhat 1.0000001, somewhat like this. As this n keeps on increasing, and as n is going very near to infinite, it can't take infinite. Okay, it's like this: 1 millionth, 1 billionth, 1 trillionth. We know till there, and 10 trillions, 100 trillions, billion trillions, trillion trillions, and that's the max capacity we can talk about. And then plus 1 is a new number. Okay, so the real numbers won't end. It has no end at all, but it approaches to infinite. So that is why we always say n tends to infinite, not n is equals to infinite or something. So n tends to infinite means very, very large number. So if it is very, very, very large number, this 1 plus 1 by very large number, very large number. Okay. So what happens to this 1 by very large number is it will eventually come closer and closer to 0. Okay, that you can observe here also. So 1 by 1 is 1, 1 by 2 is 0.5, but 1 by 100 is 0.01. This 1 by 1 million is 0.00001. So it is approaching to 0 now. So it is slowly going to 0. So as this is very, very large number, it is somewhat like 0. Some 2 lakh zeros, or 20 lakh zeros, or 20 trillion zeros, followed by 1, and which in our human world we treat it as 0. So that is why this goes 0, and this will give us 1. So what happened to the sequence is it started from 2 and slowly the next term is lesser than 2, which is 1.5 is lesser, and the next term, which will be 1 plus 1 by 3, which is 1.33, which is less than 1.5. So so you can observe every term in the sequence is, if I have this A1, A2 sequence like this. So if I look at AN is always less than AN minus 1. And this AN is less than AN plus 1. So the next term is smaller than the current term. So that you have to observe from this sequence. Okay. So these kind of sequences not only called as convergent, these are also called as decreasing sequences. Okay. So decreasing sequence, this is another type of classifying sequences. Okay. So the first classifying is either it is convergent or divergent or oscillating. And another way of classifying is whether the given sequence is decreasing or increasing, neither increasing nor decreasing. So this is another way of classifying sequences.
Excuse me, sir. So I have the same equation which you have taken, somewhat different. Can you please solve it? 1 minus 1 by n square.
Okay. So by looking
this
at
will
it,
also tend to 1.
So by looking at it, how does the sequence, see, if you don't understand the sequence right away, just write. So this is the very base thing I explained. So even though you don't know anything about sequences, you can do these things. Okay. So it's just the observation. So you have to observe what kind of sequence is that. So here also you do the same thing. So you just start taking values for n. So you start with n is equals to 1. So when n is 1, what happens? 1 minus 1 by 1 square. So this is just the nth term. So if you want the first term, you just substitute n is equals to 1. So this will give you 0.
If we institute n is equals to 0, then
see, I think in the activity questions on the top we have mentioned something.
Greater than 3.
So consider the sequences start from n greater than 0.
Okay,
so that means your first term should be treated as n is equals to 1.
Okay, sir, clear.
Okay.
Yes.
So that's how you should start. So those who don't know about sequences, you can do this anyway. You just substitute. This is just the substituting and looking at the values. 1 minus 1 by 2 is half, and so on. If you go on, n is equals to 100. If I do 1 by, sorry, this is 2 square, right? So this will be 3 by 4. 1 by 100 square, this will be 1 lakh, some 4 nines divided by 10,000. So something like this. You can see now. It started from 0. And the next jump is 0.75, and there will be some other jump, and slowly it is approaching to 1. So you can see that this is 0.9999. So very much close to 0. Very much close to 0. So like this, if I go and if I say n tends to infinite, this will be like 1 minus 1 by some very large number whole square. Large number. So I'm not substituting infinite there, but I'm saying large number. Large number. So it's like you can imagine the largest number you know and add plus 1 to it. So that will be your large number. Okay. So it's like 1 minus 1 by large number. So this 1 by large number whole square will go to 0, and eventually you will get 1. Here also an interesting thing happens if you observe. So you started from 0, and the next term is 3 by 4, and the next term might be something. So it came till here, and it is at the 100th term it is 0.9999, and so on. If it is some 1 lakh term, it will be 0.99999. Okay, something like this. So if you observe here, what is happening to this sequence, or how the sequence numbers are arranged? So you see, it's in increasing order. So you see your nth term is greater than an minus 1, so the previous term, and this anth term is less than an plus 1 term, the next term. Okay, so it's like always the next number is always greater than the current term. So that means okay, so this kind of sequences are called increasing sequences. Okay, so these are just the classifications. Okay, sequences. Okay, so if this follows this trend, this is an increasing sequence. If it follows this trend, an plus 1 is less than an minus 1, then it is a decreasing sequence. If the sequences didn't follow this or the below ones, they are called as neither increasing nor decreasing. Okay, so some sequences, like for example, some sequences
Sir,
like,
I had a doubt related to this.
Hmm.
Can I share the question?
Yes, tell me.
A0 equals 1
Mm-hmm.
and an equals whole under root of 12 plus 4an minus 1.
4an minus 1. Okay.
Yeah.
Okay, I will discuss that.
For
I will
all n
discuss.
is greater than 0.
So I will go to the recurrence relations. I didn't
So,
go
sir,
yet.
could you, sir, in this, could you explain how is it bounded above?
How is it bounded above? So I will tell you.
Okay, sir.
So I will discuss the recurrence relation. I already have one question here. Okay, so I will solve that first, and then I will go to the below one. Is it okay?
Yes.
So can you please define the divergent also?
So divergent sequences. Yeah, I will. Maybe I will just finish it off now. I will talk about that now.
Okay, sir.
Okay, so we have seen convergent sequences, right? So these are called convergent sequences. When so divergent sequences are very simple thing. When this L is either plus infinite or minus infinite. Okay, so if your L is a real number, then you say they are convergent sequences. If that particular L is getting to plus infinite or minus infinite, then you say the sequences are divergent. Okay, only this is the difference between convergent and divergent.
Sorry to interrupt, sir. Means divergent sequence are those sequence in which an is equals to plus infinity, and with the plus infinity it is also equal to minus infinity, and the convergent are only one. Either it is plus infinity or either it is.
No. Convergent sequences means the sequence will have limit value. So having limit value means when I tend n to infinite, what is happening to anth term, or maybe the last terms in the sequence, what is happening there? So are they going towards one value, which is L, and that L is a real value or not? We will write that unique.
Sir, if this unique value is minus infinity,
Then that is divergent.
then that is divergent. Okay,
Yeah.
so means
So there is either, right? Either means this or that. Okay. So if this L is a real value, unique real value means any number, any real number, then those are convergent sequences. If L is not a real number, if L is a plus infinite, then it is a divergent sequence. Or if L is minus infinite, then also it is a divergent sequence.
some little bit confused in convergent and divergence, and you have also said something that convergent is belonging to infinity to minus infinity. What you are saying about that? In convergent sequence, you use no in infinity to minus.
infinity to minus infinite. See, every real number sits inside infinite to minus infinite to plus infinite, right?
Yes, yes.
So that is what I said. If this L is any number between this minus infinite to plus infinite, then it is a convergent sequence. If that L is equals to plus infinite or minus infinite, then it is a divergent sequence.
Sir, you said that L belongs to R, all real value, and real value consists of infinity to minus infinity.
Between.
In between that.
Infinity and plus infinite and minus infinity are not real numbers.
Okay, sir. Thank you for clarification.
So this is how the number line looks. So this is the number line, and minus infinity sits outside the number line, and plus infinite sits outside the right side number line. So anything between minus infinite and plus infinite are the real values. Okay. So if your L is this, it's a convergent. If your L is this or this, then it's a divergent. Okay.
Get it, sir.
Yeah. So another classification is if L is not unique. If L is going to +1 for a few cases and -1 for few cases, or maybe something, it is going for 3 different values. So 3 different values means I will give you an example. Well, I will, after this I will go to the recursion relations. So oscillating relations are like this. Oscillating sequences are like this. So if your sequence is something like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. So this is also a sequence, right? Because everything is a real number, and they are ordered and they are kept as a sequence. So the first term is 1, the second term is 2, the third term is 3, fourth term is 1 again. So now, what will I say for this? Limit n tends to infinite. What will happen to an? So what will I say?
Does not exist.
Yeah, does not exist. Will I say it is equals to 1? Is it correct to say that will be equals to 1?
No, sir.
Or 2 or 3?
No, sir. If they all are together, then it's right.
No, it's not together. So maybe 1 is this is not correct. If I can say is equals to 2, this is also not correct. It may not be equals to 2. If I say this is equals to 3, this will also be not correct to say, because only thing I can say is it can go to 1 or 2 or 3, right? So in these cases we simply say I can't say a single unique value. So that is why instead of saying I can't say, we simply say limit does not exist. Right? In the class also, sir might have discussed this one. 1 minus 1, 1 minus 1, 1 minus 1. So this also, if I talk about limit n tends to infinite, an. So an is minus 1 power n minus 1 minus 1 power n minus or n plus 1. Okay. So nth term is this. But what will I say? Will it go to +1? Is it correct to say this? No. Or if I can say it is equals to -1 unique value -1, this is also not correct to say. So what we say is if it is happening like this, we simply say limit does not exist. Okay. So we have 3 cases here. Either the limit value exists and it goes to a unique value, unique real value, and if it is happening like that, then those sequences are called convergent sequences. The other classification is if my limit value is going to plus infinite, or if it is going to minus infinite, only one thing can be possible. Okay. So if only one thing is possible, then we simply say limit diverges to plus infinite or limit diverges to minus infinite. And the third case is if these kind of sequences, if I see these sequences like this, where the limit value is not approaching to a unique real value, it is approaching, it can approach to multiple real values, just like this cases. Then I simply say, instead of saying limit can go to 1 or 2 or 3, I simply say limit does not exist. And these kind of sequences are called oscillating sequences. Okay, so these are not that important. So your focus should be mainly on the convergent sequences and the divergent sequences.
Excuse me, sir.
Hmm.
Sir, what is the relation between bounded above and convergent or divergent or in bounded below?
That I will go. Let me talk about this recurrence relations also.
Okay,
Then
sir.
we will go to that bounded above, bounded below, increasing, decreasing, and we will connect with MCT.
Okay, okay, sir.
Okay. So now, till now, you might have seen the sequences which are properly defined or nth term is given to you. So I have given the nth term to you, right, till now. But there are few relations where the nth term is dependent on the n minus 1th term. So the previous term. Okay. So those kind of sequences are called recurrence sequences. And using that n minus 1th and n plus 1th term, we form an equation, and those equations are called, or relation, we call it as recurrence relation. Okay, whatever you are seeing, this is a recurrence formula or relation. This is the recurrence relation of the sequence. So the first term, so this recurrence relations or recurrence sequences, how they are given to you is, they will give you the first term, and then they will give you this recurrence formula, and you have to generate the recurrence using this recurrence formula. You have to generate the sequence, and then you observe. So first and foremost thing is, in this sequences, it's better you just write down the sequence and observe what is happening inside the sequence, in the sequence, within the sequence. So that's the good way to start of understanding sequences. Okay, once you understand what is actually happening, then later on you can just directly use the analytical skills you develop in the course. Okay, so so as I mentioned, there is recursions. Okay, so recursions are basically sequences where a nth term is dependent on, I hope everyone knows what is dependent means. It is dependent on an minus 1th term. Okay, so these kind of sequences, this is how it is given to us. So we'll give you the first term, so something like this, like the above case, a1 or a0. So the first term will be given to you, and then a recurrence formula will be given to you, something like this. Okay, so now you have to write down the sequence, and then also the questions might be like, find the limit of the sequence, or is the sequence being convergent or divergent, is the sequence increasing or decreasing. So these kind of questions will fall. So before going to the questions, as I said, try to understand the sequence, how the sequence is. So the sequence starts with, this is how you should think. The sequence starts with 2. Now the next thing is the second term. So what is the second term? So how do you get the second term? So in order to get the second term, you just have to equate n to 2. N to 1, sorry. N to 1 because I will tell you why. So the sequence is like this: A1, A2, A3, and so on, like this. And A1 you know, which is 2, but A2, A3, and all you should identify from this relation. So in order to get A2, so that means this n plus 1 should be equals to 2. So then only I can get A2. So in order to get A2, what I have to do, I have to substitute n is equals to 1. If I substitute n is equals to 1 here in this equation, in this recurrence formula given, so I'll get A2 is equals to 3 by 4 A1 plus 1 by A1 cube. So something like this. So now this is 3 by 4 A1 you know, the previous term you know, this is 2 plus 1 by 2 cube. This is like 3 by 2 plus 1 by 8. Okay, this will give you, this is 3, 9 plus 1, 10, 10 by 8. Okay, so this will be 10 by 8. Now you know A2 also. So instead of A2, that is 10 by 8. And 10 by 8 is smaller than 2. Okay, 2 to 10 by 8. And then if I have to get the next term, which is A3. So if I have to get A3, I have to substitute n is equals to 2 in the recurrence formula I have. So like this, if I substitute A3, I am going to get 3 by 4 A2 plus 1 by A2 cube. So something like this, 3 by 4 into 10 by 8 plus, what is this, 3 by 4 is throughout. Are people getting this? What I am trying to do?
Yes, sir.
Okay. So, okay, this will be 2 plus 1 by 8, 16, 17 by 8. 17 3 is 51. 51 by 32. Okay, so this is not 10 by 8. This will be 51 by 32. Okay, so the next term, may you have to substitute 51 by 32 and see why we are doing this is because just to understand the sequence, just to understand, I mean, whether it is increasing or decreasing, or the next terms, what is happening to the next terms? Are they coming, the difference between the terms are getting is becoming very less, or is becoming very large or more? Okay, that's the observation you should do. So 51 by 32, as right now you can use your calculators. Okay, so just use the calculators and see what happens to this number, and so on, so forth. Then you will get a sense of the sequence. Sequence is decreasing. So if it is decreasing, if it goes to some, if it has a lower bound, it is decreasing, and if it has a lower bound, I can use MCT and say this has a limit value. Okay, and that I will come later. But as of now, once you observe the sequence, it will give you some sense of the sequence. It will automatically give you ki, yeah, this goes to some limit, the limit exists. And if you are convinced that the limit exists, then I will give you a very this is discussed in the lecture also, very good step or method where you can use it for recurrence relations, these kind of recurrence relation problems, and get the solutions. So that step is like this. So if you are convinced, so this is the first thing. So after observing the sequence, if you are convinced that the sequence AN has a limit, has a limit value, I already said, has a limit value means the sequence is approaching to a unique L. Okay, so if you are convinced about this thing, so what you do is, when n tends to infinite, what this is, limit value is becoming L, means when n tends to infinite, limit n tends to infinite, an will be equals to limit n tends to infinite, even an plus 1, I can write, this will be equals to L. So both of them will be equals to L when n tends to infinite. So I was talking previously also, A2, this is the sequence, if this is the sequence, this is the nth term, and the last terms. So if all the last terms will be equal, so you can treat it as equal. So if the limit value is existing, then these last terms are equal. So that is what I did. When n tends to infinite, so this term and its next term or the previous terms, all the values will be equals to L. So this thing I can use. So you have to use this thing, that's it. So you bring the step 1 is take the recurrence formula. Take the recurrence formula. Recurrence formula, what you have is an plus 1 divide an plus 1 is equals to 3 by 4 of an plus 1 by an cube. So this is what you have. And step 2, take limit on both sides. So once you take limits on both sides, limit n tends to infinite, an plus 1 is equals to 3 by limit n tends to infinite, 3 by 4 of an plus 1 by an cube. Okay, so you are just taking limit on both sides. And also I will tell you, you can cut down this step 1, step 2 once you practice more and more problems. So I'm giving a detailed stepwise method how we solve this.
But sir, if we have root, then how do we solve like in the question?
I will tell you. I will take that example also. Okay. So this is, so now in step 3, just once you are convinced about this thing, maybe step 0. So this will be step 0. So it's like pre step. It's not involved to any of the. This is the step 0 will be for every recurrence relations, unique for every recurrence relation problems. So now step 3, what you do is you just substitute step 0 in step 2. Okay, so substitute what you have in what you know in step 0 in step 2. So what I know, limit n tends to infinite, an will go to L. This will be equals to this, using the limit properties. I can write it like this: 3 by 4 limit n tends to infinite an plus 1 by limit n tends to infinite an whole cube. So again, the same thing. So even this will also be L. This will also be L. So ultimately, what will I get? L equals to 3 by 4 L plus 1 by L cube. Okay. So from this, I just simplify this and I will get the value of L. Okay, if I simplify this, what will I get? L is equals to some 3 by 4. So this is L power 4 plus 1 by L power 4. And this will imply me. So if I cross multiply this, I'm going to get 4 L power, sorry, this is L cube 1. 4 L power 4 is equals to 3 L power 4 plus 3. And from here, I'm going to get, if I bring that 3 L power 4 to the left hand side, I'm going to get L power 4 is equals to 3. So from here, I can take fourth root on both sides. If you take that, we are going to get L is equals to 4th root 3. So what does this say? L is equals to 4th root 3 means, this is saying me that limit n tends to infinite, this an is equals to 4th root 3. So what I got this particular sequence, recursion sequence, which is given to me, is actually converging to 4th root 3, and it is a unique value. It's a unique value. So I can say if it is going to a unique value, then I can say this sequence is a convergent sequence. Okay. And the next thing is one more thing is also there, whether this is increasing or decreasing.
Hello.
So how do I prove? Yeah.
There are someone waiting for to join the class. They're not able to join.
Oh, okay,
Can you
okay,
please?
okay. Yeah. Sorry. I was in the other screen. So
Please.
yeah, I admitted that. Thanks for.
Okay. Please continue.
Yeah. So in recursion sequences, you know how to classify whether it is convergent or divergent. So if this is sequence, while you solve this, if it is going to a unique value, then I say it's a convergent sequence. But how do you say whether it is an increasing or decreasing? For that, it requires some sort of mathematical skills or analytical skills. So if I have to conclude whether it is increasing or decreasing, I have to prove. So in order to prove increasing, I have to show that an plus 1 is greater than or equals to an for all n. Okay, this is what I have to show. For all n, I mean n is equals to 2 or 3 or 4 or 5. For any n, I need to show that an plus 1 is greater than or equals to an for increasing.
Can you please go up a little bit? I forgot to note on one step.
I will give you the slides.
Okay then, yeah.
Okay. So in order to,
sir,
yeah.
Where L and L plus 1 by L3 came, that step, sir. Please explain, sir.
Which one? This one,
sir. From beginning, sir. From substitute, next step, sir. Step 3, sir. Step 3.
Okay. Step 3. Step 3, you just have to do this. So limit n tends to infinite an is equals to small n. Limit n tends to infinite an plus 1 is also equals to small n. Or in some cases, what happens is this is actually equals to this also. Limit n tends to infinite an minus 1. So that is what I am explaining. If n is tending to infinite, all the terms at the end of the sequence will be equal to a single value L. Okay. So even though you see this term or the next term or the next term or the previous term or the previous term, at the end of the sequence, all the real numbers, all the real values will be equals to L. That is what I am using here. So in step 3, whatever the recursion relation, recurrence formula I have, after taking limit on both sides, so one side I have limit n tends to infinity an plus 1, which is L. On the other side, I have limit n tends to infinity an. That is also equals to L, small l. So I just substituted that here, and I got the equation as L is equals to 3 by 4 L plus 1 by L cube, something like this. Okay, and I simplified it. The next steps are just the simplification. So I just I did the LCM, and I am going to get L power 4 plus 1 by L cube on the right hand side, and I brought that 4L cube to the left hand side, and it will become 4L power 4 is equals to 3L power 4 plus 3, and then it will be L power 4 is equals to 3, and I took 4th root on both sides. I got L is equals to 4th root 3. Okay, so this is just the simplification thing I did.
I think, where is that 4? 4L4.
This.
No, after the step, after that step.
After that step,
L4, you have taken L4, it has to come below down, right? By 3.
Sorry, Okay, maybe I will simply say multiply 4L cube on both sides. So if you multiply 4L cube on both sides, what will you get the left hand side?
L 4L cube.
So already there is L. If I multiply 4L cube, I will get 4L.
That step I got it. The next step. Yeah. After
Then
that.
after
Yes.
after that, this is 4L power 4.
Yes.
This is 3L power 4.
Okay.
So I just got that, or maybe I just subtracted minus 3L power 4 on both sides.
Got it. Yeah.
Okay. So
excuse me, sir. Sir, if in the graded assignment of week 3, there is a question where the answer is infinity. So, sir, how we type infinity in this assignment? It is not accepting that.
Maybe I will give you a hint. Maybe the answer is not infinite.
Okay, sir.
Okay. So try solving it again. Okay. So I will come back. I will come to this increasing, decreasing later. Let me solve a few more problems for getting better hand on this recursion relations. Okay, I will take this example. I will take this example now. A0 is equals to 1 and an is equals to, yes, so this is problem 2. Yes, any doubt? Someone raised your hand, right? Okay, anyway. So as I mentioned, step 0 should be, you should convince that, or for understanding, let us write down the sequence first. So n is equals to 1 will give me a1 is equals to root 12 plus 4 times 1, which is root 16, which is 4. Now when n is equals to 2, I'm going to get a2, which is 12 plus 4 times a1. a1 is 4, so 4. So 16 plus 12, which is 28. Okay, square root 28 is actually 2 root 7. Okay, and then the next sequence, so the next number will be square root 12 plus 4 times 2 root 7. And this is something like 12 plus 8 root 7. Correct? So like this it will go. So it started from 1. Okay. So let me just use the calculator and show you. So it started from 1, a0, 1. So you see the difference between these two, it is 3. Correct? First term and the second term is 3. And then square 2 root 7. This comes very much near to 5.29. And you see the difference. This is 1.29. So which is lesser than the 3. And then this thing, square root of 12 plus 8 root 7. Square root of 12 plus 8 root 7. I'm going to get somewhere 5.758. Okay, you see the difference. This is 0.3. So let me say this is 0.3. Very much close to 0.3, and this is 1.3. And this also 0.76, 0.8. You can take point. Oh, it won't go 0.8, I guess. 0.76. Okay. So this is a difference of 0.46. So now you can observe this thing. So the difference between the terms are reducing, slowly reducing, and the sequence you see, it is 1 first, 4, 5.3, 5.76. So it's an increasing sequence, but the increase is not constant. So the increase is slightly decreasing. So the increase in the terms are slightly decreasing. So this is what I meant. The difference between the terms are huge at the start, but later on it is slowly decreasing. So this is 3, 1.3, 0.46. So if you go for the next term, this will be somewhere around, I'm not sure, but somewhere around this will be 5.765 or something. So the difference will decrease. It will be increasing, but the difference between the terms will decrease slowly. So observing this thing, you can slowly convince yourself that, yeah, this is approaching. If I go on in the sequence, slowly the difference will slowly gets to 0. And
yes, sir, that is clear that it is bounded below. But then how do we check for bounded above?
See, bounded above is like this thing, right? It started by 1. It started with 1. And every term in this. So this is, okay, this is bounded above is mean. So what do you mean by bounded above?
Like maximum.
So bounded above means this. So in your sequence AN, so for any n, AN is less than or equals to some m, where m is a real number. Okay. For any n, so n can tend to infinite also. If your sequence numbers are less than or equal to some value m, then we say the sequence AN is bounded above. Okay. So what does this mean is, on the number line, I'll show you. On the number line, if you plot your sequence numbers, so if you plot your sequence, so maybe if your first number, let me take this sequence only. Your first number started with 1, then 4, then 5.3, 5.76, 5.765, which is like this. So if I had any m here, and if you are sure that none of your sequence numbers will cross this m, so any number you pick from the sequence that will be less than or equals to this m, then you say this is bounded above sequence. The sequence is bounded above, and it is the value is equals to m. So this is the bounded above means. So there will be a real number m where any number in your sequence will not cross the 10. Okay, will not go above the 10.
So what is the m for this equation, this question?
For this question, m will be if this is having a limit. Okay, if this is approaching a limit L, then you are pretty much sure that any number on this in this sequence will not go above L, right? Am I correct? So this is an increasing sequence. These values are slowly increasing. But if I am sure that this sequence has a limit value, okay, limit value means as n tends to infinite, it will approach to that particular value L.
Sir, also called non-decreasing.
But the statement
non-decreasing sequence.
Non-decreasing sequence means sometimes the sequences have same values also.
But the statement is confusing, sir, because if the m is the limit, if all other terms comes after the m, then maybe the bounded above is
no. See, bounded above means there is an value m, so it's above the sequence.
Sir, like this type of equation question, if we get, how we get that it is above bounded. If we take n is equals to 1, n is equals to 2, n is equals to 3, and if we set the increasing in the value is decreasing, means then it is bounded above.
That's a valid question. How do you check for bounded above? Means if this sequence has a limit value. Okay. So if the sequence has a limit value, or that is what I am saying, right? If you can come up with this m, some m. So for this sequence, if you say 20, so it will not cross 20. If I can say it will not cross 20, any number in this sequence will not cross 20. Okay. So will you be agreeing to my statement, or is there any number which crosses 20?
Sir, how you get this 20? This number?
I didn't get 20. It's not 20 actually. I just said by observing this, you see the values 1, 4, 5.3, 5.76 and 5.765 and so on. By looking the trend of the sequence, maybe 100. Can I say any number in this any number from the sequence will not cross 100? Will not go above 100. Can I say that?
You mean
Yes,
left
sir.
of
You can
left of
assume,
100.
sir.
Is my assumption correct or wrong?
Correct.
Yes, sir. Yes, sir.
100. So that 100, can you optimize it or not, is what we are going to see. So do I really need to go till 100 and say that any number in this sequence will not cross 100, or is there any value, any better value than 100? So from 100, can I reduce to 50? Can I say none of the numbers in this particular sequence cross 50?
Yes, sir.
50?
Yes.
50 looks little valid. Can I say 25, 20, 15, 10? 10? 10 might look confusing. You might say if I keep on increasing, I might get at one particular n value, I might cross 10. Right? That is what you can say. So for that, what I can say you is, I know this particular trend, whatever the difference is slightly getting lower, right? Or the sequence numbers are coming closer and closer to each other, right? At some point, it will become very much close to 0. So the difference between the numbers will come closer and closer to 0. Correct? And at that particular point, whatever the values I have, they all will be equal to a particular value, right? L. And any number in this sequence will not cross or go above L. Agreed?
Yes, sir.
Actually, the difference only cannot go above L, right? Not any number in the sequence.
Difference?
It's only the difference between subsequent terms in the sequence
will go to 0. Will go to 0, right? So what does when if it goes to 0, how will the sequence look?
Constant at the
constant, right? From that particular point, it will be constant.
Correct.
Right? Constant means some value. That value will be for the next term. Next term also will have the same value. Then only the difference becomes 0. Right?
No, correct.
So now it will become a constant. From here it will be a constant L. And all other numbers left to L are lesser than L. Agreed? Agreed to this point also. So whatever sequence values you have here, they are all less than L, because this is an increasing.
So sir, in this, how do we find the limit? Could you also show that?
I will show that also. But firstly, convince that the sequence started from 1, the next term is 4, and slowly it is going to 5.3, 5.76, 5.765, and so on, so on, so on. But the difference is difference between the terms are coming closer and closer to 0, and at some point it will be very much equal to 0, and I treat it as 0, and then later on,
that
and
will
then
be the limit.
and then on it will all be L, and the limit value will be L. And by looking this, can I say my sequence, this sequence AN is lesser than or equals to L for any n? Can I say this?
Yeah.
Yes. Sir, please, one
Yes,
second,
sir.
sir. Please repeat.
Repeat. Okay. So when I look at the sequence, if my sequence is increasing and the way in which it is increasing, you have to observe. So it is increasing sequence, but slowly what is happening is the increase. So the increase happening between the terms is slowly coming to 0. So if it is slowly coming to 0, at some point it will be very much closer to 0, and I treat it as 0. So if the difference between the terms are becoming 0, then that means the terms are equal, slowly becoming equal. And if that is becoming equal, then I treat them as same values, L, and now here the difference you see that will be 0. And this L will stay till the infinite. So it will not go above L. And what I mentioned is all the terms in this particular sequence are either less than L or equal to L. So that is what I said. So can I say for any n, my AN, so the sequence numbers are less than or equals to L. So if I can say this, then I can say the sequence is bounded above. Okay, if I am sure that if you can come up with some L, or as I said 100 is also okay. So if you can, if you are convinced that my sequence, whatever the sequence entries or the sequence terms, if you are sure that it will not cross 100, I can say simply for any n, my AN will not cross 100. If you have an upper bound, so it's like upper bound to the sequence, okay, then I can say the sequence is bounded above. So bounded above means there is a value which is above the sequence, and the whole sequence will not cross that. So it is bounded, closed. Okay, it is closed there. So if it is closed, the sequence cannot go outside that. So the sequence lies inside that only. Okay, that is what bounded above means. So if it is bounded above, then how do you find this L? So we are interested to find this L. So let me compute that L. Let me remove this. So just remember, so if you are convinced that the given recurrence sequence has a limit value, then the step 0 should be limit n tends to infinite AN minus 1 is equals to limit n tends to infinite AN is equals to limit n tends to infinite AN plus 1 is equals to L. Now I'll start with step 1. Take that recurrence relation with you. So the given recurrence relation is AN is equals to square root of 12 plus 4 AN minus 1. Okay. So now take limits on both sides. So if you take limit on both sides, this will be limit AN n tends to infinite AN, and this will be limit n tends to infinite square root 12 plus 4 AN minus 1. So this is using the properties. I can take the limit inside. Okay. I can write it like this: 12 plus 4 times limit n tends to infinite AN minus 1. So as these are the very first examples, I am writing each and every step. The next examples, what you do is you simply replace an with this small l and an minus 1 with this small l. That's it. You don't need to write all these things. So now what I will get by using this step 0 thing I can simply write L is equals to root 12 plus 4 times L. Now I got an equation in terms of L. What I have to do, I have to solve it. Square it on both sides. I'm going to get L square is equals to 12 plus 4L. Right? If I square on both sides, I'm going to get this. Then bring everything on one side. L square minus 4L minus 12 is equals to 0. This forms a quadratic equation. So how do I solve this quadratic equation? Use the quadratic formula, or you just split the inside, the middle term. So I can write minus 6L plus 2L minus 12 is equals to 0. So from here I am going to get L. If I take L common from the first two terms, I am going to get L minus 6 plus, if I take 2 common, 2 times L minus 6 is equals to 0. So from here I am going to get L is equals to minus 2 or L is equals to 6. Now my first question is, are both the values possible for L?
No, sir. The minus two is invalid.
Is minus 2 possible?
No, sir.
No, sir.
No, sir.
Why?
Sir, because it is bounded at 1.
The lower bound is 1, or if you look at the sequence, this is why I suggest you, if you have the sense of the sequence, then you can directly see. You see, it is started from 1 and it is going to 4, 5.3, 5.76, 5.765 and so on. It is an increasing function. Slowly it is increasing and it is going to some value L. So this L cannot be minus 2 suddenly. So it's an increasing and it's greater than 1. The sequence is greater than or equals to 1. So it cannot go to minus 2. So but why did we get this minus 2? From where we got this minus 2? Okay, maybe from here. So while I took the square on both sides, this will allow few more values to satisfy this. Okay. So
Yes,
if I do this backwards, if I just square root it on both sides, what I will get is mod L. So you have to take mod, because square root is always positive. Even here also you can check, if L is minus 2, the left hand side is minus 2, but the right hand side will be some positive value. Square root of something is positive always. So it will not satisfy. So as we did this square, so that is why we got this extra value. But this is not correct. This is not correct. The only value that L can take is 6, which is logical to see also. You can see it can be 6 also. So slowly it is approaching to 6. So that will be your limit value for the given recurrence sequence. Okay.
Sir, we can say this non-decreasing sequence.
You can say this is non-decreasing sequence also. So non-decreasing, the difference between increasing sequence and non-decreasing sequence is, in non-decreasing sequence, so this is a non-decreasing sequence. 1, 1, 1, 1, 1. So this is a non-decreasing sequence. Okay. But not increasing sequence. Okay, non-decreasing means it should not decrease, that's all. It can stay same or it can increase. Okay, so that's the difference. So all the increasing functions, you can call them as non-decreasing also. But not all non-decreasing functions are increasing functions. Okay.
Yes,
so
sir.
shall we do one more problem on recurrence
Sir.
relation, or let's proceed to MCQ?
Sir, I have one question on recursion. One equation. An is equals to half 1 by 2.
Half
Plus
हाँ
ब्रैकेट में -1 raised to the power n.
हाँ
into में 1 by n multiply by 1 by n.
Into 1 by n.
Yes, sir.
This is not even a recurrence relation.
Sir, limit. Sorry.
So you want the limit of this.
Yes, sir.
Okay. So, okay, before going to this example, I just wanted to ask, are there anyone who has a question on recurrence relations or recurrence sequences? Anywhere
Sir,
in... huh?
Sir, I have one doubt. It's on the graded assignment, on the recurrence.
Graded assignment, I don't think. Okay, maybe just ask the question, then I will decide whether to answer that. Or...
No. Question number 7, I guess it's not a recurrence. Sorry. Question number 7, it's asking an limit of n tends to infinite, an and bn. So an is coming finite value, but bn it's coming sort of infinite.
Oh, bn is coming. If an is finite, any function
bn
of an will also go to finite, right?
bn is basically quadratic.
Yeah. Yeah. So
here should I apply this MCD sort of simple quadratic? So
okay. Yeah, I will give you a small hint here. Okay. So if you know an has a limit value, or if you know that limit n tends to infinite, an is equals to some L, then can you comment on this? What happens to this limit n tends to infinite an square?
So
infinite.
This will go to infinite, or this will also have a limit value?
No, infinite.
Infinite. Why?
Because it keeps increasing and it's square.
It's not increasing. Who said it is increasing?
Increasing, I mean, yeah, it's square.
Okay.
So divergent.
Okay. Most of you are. Can any one of you in the session can tell me the answer for this? What I wrote?
L square.
L square.
Sir, I think so. L square, sir.
So it will go to L square. So why it goes to L square is the question. Okay. So now you see, if I am saying limit n tends to infinite, an is equals to L. What does this mean? This means that I have the sequence with me, a1, a2, and so on, an, and so on. But after some time, my sequence is slowly started approaching to L. Correct? Sequence becomes a constant and it becomes L. So then only I can say this particular limit exists, limit of this sequence exists. So if this is the sequence for an, what will be the sequence? How will the sequence of an square look? a1 square, a2 square, and so on, an square, and so on. After some time, even that an goes to some constant L, right? That is what this says me. So if that is the case, this will go to L square, L square, L square, and so on. Right?
Yeah, understood.
One good example you can think of is you take the example of 1 minus 1 by n as an. Okay. And you see what is an square. An square is 1 minus 1 by n whole square. Okay. So you compare. So if this is going, you just compute what is happening to this an, limit an tends to, sorry, limit n tends to infinite an. What is happening to this? If this is the thing, what will happen to n tends to infinite an square. So will it go to infinite or?
So it is also one of L only. Sir, like if we want to solve this limit, we will take limit n is equals to infinity 1. Then in different bracket we will take minus limit n is equals to infinity 1 by n. Can we solve it like that, or
that is the thing, right? You have to do it in, if you want to do it stepwise, then this will be
sir, yeah. So this 1 by n becomes 0.
This will become 0 and this will
And
be 1.
Become 1. So the an square is also 1.
This will also be 1. Okay. This is 1 because it will go to 1 square and 1 square is 1.
Yes.
If you take 2 and 2 here, you will observe that this will go to 2 and this will go to 4.
Yes, sir.
Okay. So that is what it states. See, if limit an is going to some L, you have many properties, right? One good property is limit n tends to infinite an times bn. This I can write, if both the limits exist separately, then I can write an times limit n tends to infinite bn. I can write this, right? So instead of bn, if I take an only, what happens? This is what happens. Limit n tends to infinite an square will be equals to limit n tends to infinite an whole square. So we'll get it. Okay. Okay. Let me solve this problem then. So if none of you have any questions in recurrence relations, I will take this example now. So let us do this. It is half. An is given to be half plus minus 1 whole power n 1 by n. Okay. So first and foremost thing is understand or observe how the sequence is. If you want to observe, you just substitute n is equals to 1. You will get the first term. So what will be the first term? A1 will be 1 by 2 plus minus 1 whole power 1, 1 by 1. So this is something like half minus 1. This is minus half. Okay. And then see n is equals to 2. This will give you a2, half 1 plus minus 1 whole square times 1 by 1 by 2 times 1 by 2. This will be equals to half plus half. This will give me 1. And then see n is equals to 3. A3 will be half plus minus 1 whole cube 1 by 3. So this is half minus 1 by 3. Correct. This will give me 1 by 6. Right. And then n is equals to 4, a4 half plus minus 1 whole power 4, 1 by 4. This will be half plus 1 by 4. This will give me 3 by 4. Correct?
Yes, sir.
And then 5. So if you see, you can also get the 5 half minus 1 by 5. This will give me 3 by 10. Okay. So slowly it goes like this. And if I see a100, this will be half plus minus 1 whole power 100, 1 by 100. This will give me half plus 1 by 100. And if I see a101, the very next term, this will give me 1 plus half plus minus 1 whole power 101 divided by 101. This is half minus 1 by 101. Okay. So this is how it is. So let me just write the sequence now. So it started from minus half, 1, and then 1 by 6, 3 by 4, 3 by 10, and so on. At some point it is half. So the before term is A99 is half minus plus minus 1 whole power 99 divided by 99. This will be half minus 1 by 99. Okay, this will be like this. Half minus 1 by 99, comma half plus 1 by 100, comma half minus 101. And if I still go on and look at 1,99,999 and 1,01,000, I will be getting like this: half minus 1 by some 99,000, half plus 1 by some 1 lakh, comma half minus 1 by 1 lakh, something like this, and it will go and so on. So this is how the sequence is. So slowly you can, so if I plot this on number line also will give you much more understanding. So you slowly plot your A1, A2, A3 and so on the number line. So let me say this is 0, or maybe I'll take 0 slightly here. This is minus 1. This is 1. Maybe half I will take. And this is 1. Okay. So this is minus half. So something like this. So where was our A1 started? It started here. So this started here. So this is A1. The first term started here. Then where is our second term? The second term is here, A2. The third term is 1 by 6. 1 by 6 is somewhere here. Okay, and this is the third term. And where is my fourth term? It is 3 by 4. 3 by 4, somewhere it will be here. And this is A4. Now you see, by looking at 4 terms itself, you see A1 started here, A2 went here, A3 here, A4 here. So how is the sequence? Is it increasing or decreasing, or neither increasing nor decreasing?
Neither increasing nor decreasing, so
neither increasing nor decreasing. You see this pattern. So it started here, it went here, and then here, then here. Then the next term is 3 by 10. So the 3 by 10 will be here, 0.3, somewhere here. So this is 3 by 10. So this will be A4. And you see the oscillation. So it is going forward, backward, forward, backward, forward, backward. And you see this half minus 1 by 99 will be here, somewhere here. And half plus 1 by 100 will be somewhat on the right side of half. And again, this half minus 101 will be left side of half. So slowly, and the difference is slowly reducing. So if you go on with the sequence, it is slowly like half minus some small number which is very much equal to 0. And the next number is half plus some 0.000000001. And the next term is half minus the term where the number is very much close to 0. So slowly it is going closer to half. Slowly at some, after a few numbers, you can simply write slowly. What happens is it will become stabilized. It will slowly become half.
Got it, sir. Got it.
So the limit is half for this. Okay. So this is why I suggest you, while you solve the problems, get the sense of the sequence, what is happening in the sequence. And if you solve before the exam only, then only you will get the sense. By looking at the sequences, then you will directly get you will develop this sense slowly. And when you look questions in the exam, then instead of doing all these things, fancy things, which I did, you will by looking at the sequence itself. Here also you see the sequence half plus minus 1 power n 1 by n. So by looking this 1 by n, you know that when n tends to infinite, this goes to 0.
Yeah, sir, I have
So it
made a
goes to 0.
mistake in the calculation.
So this goes to 0. That means this term will vanish off slowly, and I will be left with half. So this is what you can develop slowly. Okay. So see the difference. So this I did it in 4-5 seconds. So 5 seconds and that 10 minutes. So you can reduce the time spent on these questions only when you solve more and more problems. Okay.
Yes, sir.
So let's move to MCT now. Okay. So this monotone convergence theorem. So whatever we discussed, that we more or less discuss the same thing without using the terms and all. That's it. Okay. What this monotone convergence theorem says is, this has two statements which are more or less same statement, same kind of statement. One statement says, if a sequence is, maybe I will just say non-decreasing, better way to say, if a sequence is non-decreasing and bounded above, then the sequence has a limit. This is one statement. The other statement is the vice versa, not the vice versa. If a sequence is non-increasing and bounded below. So I discussed bounded above. If I talk about bounded below, how would I define that? So just recall how I defined bounded above. So I need to come up with a real number which is above the sequence, and also I'm sure that none of my sequence terms will go above that particular value. Now using the same thing, if I say bounded below, how do I define bounded below now?
No term shall go below that.
That's it. So bounded below means, bounded below sequences means, for any n, if I have my an is greater than or equals to, or I will write it in this way, small m less than or equals to an. So any number you pick in your sequence, any term you pick in your sequence, that shouldn't be less than some value m. Okay, some value. Then I say, then the sequence is bounded below. Okay. So this sequence is the sequence bounded below? Think and answer me. Is this sequence bounded below?
No, sir.
No. Any other answers? No, yes. Thinking.
Sir, it's getting the minus value and plus value both, no?
Both. But see, I never said m, that small m is positive or negative.
Okay,
So,
then it's
below is minus 1 by 2.
Minus 1 by 2 acts as any number less than minus 1 by 2 you take. So if I say minus 1, so none of my sequence values will be less than or equals to minus 1. Yes or no?
Yes, sir.
So minus one acts as a lower bound for me, right?
Yes, sir.
Can I do better than minus one is what we are concerned about. So can I do better than minus one means can I have one more value for m which is greater than minus one, and also I can proudly say that none of the sequence terms are lesser than that value. Is there any number like that?
-1/2.
-1/2, correct. So now I can, in this particular sequence, I can proudly say that minus half.
Sir, -3/4 if we take.
-3/4 is also a good lower bound, but minus half is better than -3/4. No?
Yes, sir. Yes, sir.
So I can say minus half will be lesser than or equals to any number in this sequence. Any number in this sequence. Correct? See, my A1 is minus half, but none of my other terms will go below this minus half. See, these numbers are oscillating here around half. All the numbers will be somewhere here. Okay. So I can say this sequence is bounded below, and the lower limit or the lower bound is equals to minus half. Okay. And is this sequence bounded above?
Yes, sir.
So what is the best bounding value?
1.
1. So I can also say none of my sequence values will be greater than, or every sequence number, a sequence term will be lesser than or equals to 1. So I can write it is upper bounded. This sequence is upper bound, which is equals to 1. Okay. So this sequence is bounded above as well as bounded below, and these kind of sequences are simply called as bounded sequences. Let me write that also. So if it is bounded below is this, bounded above means for any n I have an less than or equals to this capital M, then the sequence is bounded above. And now the definition of bounded sequences are: if the sequence or like this, for any n, if I can write this m less than or equals to an less than or equals to m, capital M. So it's less like it is satisfying both bounded below as well as bounded above. So if I can come up with these values m and capital M, any value, if there exists any value m and n like this, then the sequence is bounded. Okay. So example is this. So you can take this as an example. Half plus minus 1 whole power n 1 by n is a bounded sequence. Okay. So yeah, after knowing these things, let's go to this monotone convergence thing. What this is. So if you have any sequence which is non-decreasing and bounded above, okay. So non-decreasing means the sequence on the number line. So this is on the number line. If it is non-decreasing means non-decreasing or increasing means. So if my first term is here, if A1 is here, A2 should be right of A1. So it should either A2 should be on A1, the same value A1, or it should be right of A1. So something like A2 should be like this. And next A3 should be either equal to A2 or greater than A2. Greater than A2 means right side of A2 on the number line. So like this. So A3, A4, A5, A6 and so on. So the sequence should be like this and also bounded above. So bounded above means, as I said, there is an M, capital M. So there is a capital M, which will act as an door, closing door at that particular point. Okay. Now you see this is slow, non-decreasing sequence, and also it is bounded above. Bounded above means this sequence will not cross this. So it's increasing. It is going towards right side. It is going toward right side as well as it is not crossing some value. So if these two things are happening, intuitively also you can think that, yeah, this sequence slowly goes to one particular unique value, right? It looks like that, right? So you are moving forward slowly. Treat it like this. You are moving forward and each step you are taking, each next step of yours is slowly moving towards a door, and you are pretty much sure that you are not going to cross that door. Then what eventually happens? You will stop at one point, right? You won't move. Am I correct? So you are maybe some inside your bedroom or somewhere, and you wanted to walk towards your main door. You started walking towards the main door, and you don't want to cross the main door. And each time you walk, you are moving forward. You will move forward, and you won't cross the main door. Then what does this imply? This implies at some point you will stop walking. Then only you can't cross the door, or else you will cross the door. If you are moving, then you will cross the door. At some point you won't cross the door. At some point you will stop. You will stop means the sequence has a limit. The sequence is not increasing, not going to increase. Okay, it will take a constant value at some point. So that is what this monotone convergent theorem says. So if I have a sequence, non-decreasing sequence and bounded above, then the sequence has a limit. And the second statement is more or less the same thing in the opposite direction, but in the opposite direction. So if a sequence is non-increasing, can someone see? Even I am hungry. Okay, so if you're eating or doing anything, please be on mute. Yeah, any doubt? No, right?
No, sir. No, sir.
Okay. So the second statement says this thing.
Hello.
Yes.
Is it like a pendulum sequence, right? Maybe.
No, it's not a pendulum sequence. It's
Okay.
actually an increasing sequence, right? It's
Okay,
slowly
okay.
it's slowly moving towards M, but it's not crossing M.
Crossing the limit. Okay. Right.
So like that. So the second statement says it's a non-increasing function. Non-increasing function means the first term will be this A1. If it is non-increasing, the next term should be either equals to the same term, or it should be left side in the sequence, or it should be less than the first term. So it will be somewhere like this. This is A2, and the next term should be either less than A2 or equals to A2. So this will be A3, and slowly. So this is what the non-increasing sequence looks like. And if it is a non-increasing sequence as well as bounded below. So now bounded below means, again, there is an M, small m, where none of my sequence terms will go below the term. So that means, again, it's in the opposite direction. Just now what we discussed, it's in the opposite direction. This sequence slowly moving towards the term, but it is not going left side of M, lesser than M. Okay. So what does this say? Again it says the same thing. So it will slowly eventually goes and becomes a constant at one point, right? And somewhere all the sequence will go stop at somewhere. It will not go below that. Okay. What does this mean? This will have a limit. That is what this monotone convergent theorem says. Okay. Now you can use this on the above examples somewhere where I used these things here. All the recurrent sequences you can use this here. So you see this. That is what we tried to explain. I tried to explain, and we are trying to get the intuition of the sequence. So this is an increasing sequence, and it is increasing. It's an increasing sequence, and also I know that this sequence will not cross some 10 or 20 or 30. So there is an upper bound for this. There is an upper bound and also increasing sequence. Then I am pretty much sure that the limit exists. If the limit exists, after some terms, all other terms will be very much closer to this L. So I can simply use this thing, limit n tends to infinity, an minus 1 equals to an is equals to limit n tends to infinity, an plus 1 will be equals to L. So this thing I can use using monotone convergence theorem. So after I can use this, just substitute that L here and get the answers. Okay.
Yes, sir.
Okay, great. So we will do a couple of problems on this. Couple of problems I wanted to do, and then we will end this session. So if you guys have any doubts in activities or practice assignments, you can give me. We will solve it.
Yeah, I sent one question in the chat.
Okay, let me just take a look at it.
3.7. Question number
4, 2, 3.
Oh yes.
Okay. So let me just open that and see. 3.7. Second, third, and fourth. Right? Maybe I have to share the screen, I guess. So why I don't share my whole screen is because there are some important things. Sometimes I will forget to close. Okay, maybe I will just quickly share the tab which I wanted to share. Yeah. So is my screen visible? This 3.7 screen.
Yes.
Activity question screen. Right. So these are a few questions we will tackle. Now question 2. Let me start with question 2. Consider the sequence like this, and the sequence is defined as this is what it means. This gives you the nth term for you. So the nth term is 1 plus n cube divided by 40 minus 4n square. So again, as I said, once you see this, you get the sense of the sequence, how the sequence is looking like. So what will be the first term in the sequence? It will be 1 plus 1 divided by 40 minus 4 times 1. So it is 2 by 36, which is 1 by 18. Correct? So that is 1 by 18. It will start at 1 by 18. And then slowly, for the next term, what happens? 1 plus 2 cube, which is 8. 8 plus 1 is 9. So 9 divided by 40 minus 4 times 4.
Yeah. So, but what we gone through this, we are dividing by the largest power, say n cube, 1 by n cube.
If you know that techniques and analytical, if you have that analytical skills, maybe I will just skip directly to that.
Okay.
So if you divide a numerator and denominator by n cube, what are we going to get? 1 by n cube. In the numerator, we are going to get 1 by n cube plus 1. Right?
Yes, sir.
Okay, maybe I will go to the back screen and I'll just write this question there. That would be, I like writing. Okay. So let me talk about AQ 3.7 question 2. So there the sequence is given as 1 plus n cube divided by 40 minus 4n square. So if you have the sequence and if you are interested to compute the limits, limit n tends to infinite, 1 plus n cube, write the nth term, 40 minus 4n square. So for this, we have some tricks or tips were given in the lecture. What you have to do is you divide it by highest power. So the highest power is n cube. 3 is the highest power I have, so I have to divide it by n cube in numerator and denominator. If I divide, this is what I am going to get. So 1 by n cube plus 1 divided by 40 by n cube minus 4 by n. Right? This is what I'm going to get, right? Is this clear?
Yes.
Yes, sir.
Now I can take limits onto numerator and denominator separately. So limit n tends to infinite 1 by n cube plus limit n tends to infinite 1 divided by limit n tends to infinite 40 by n cube minus limit n tends to infinite 4 by n. Right? Now tell me what will happen to each of the limit. So what will happen to this limit?
0.
This will go to 0. This
0.
0. This
0.
0. So what you are getting is 0 plus 1 by something 0 minus 0, which is 0 anyway. Okay. So you are getting something, some non-zero value divided by 0. So where will this go?
Infinite.
Okay. So I will tell you one trick. Okay, one trick.
But in the answer, they given us different.
Oh, is it?
Yeah, it was. It is given as minus infinite.
Sir, I think denominator should be non-zero.
Ah, okay. Sorry. Just a second. Yeah, this is what happens sometimes. See, that is why getting sense of the sequence is much important. See where it started actually. See this minus in denominator also, this minus plays a very big role. You know, this is minus 40 minus 4n square, correct? Even this 0 minus 0 also, where this 0, is it approaching 0 from the left hand side or the right hand side? It matters that. So that is what I wanted to convey. So here I will see, having the sense means, you see when n is 1, it is 2 by some.
Sir, I think instead of n cube we can divide by n square, so denominator would be
that also you can do. That is also, yeah, I can divide it by n square. Yeah, I can divide it by n square. So if I divide it by n square, what will I get? I am going to get.
There is no limit if you divide by n.
Limit n tends to infinite 1 plus n cube divided by 40 minus 4n square. If I divide it by n square, then I am going to get n tends to infinite 1 by n square plus n divided by 40 by n square minus 4. Okay, this will be equals to the upper limit this will go to 0 and this will go to infinite. The above will go to infinite, but the below, if you see 0 minus 4, this will go to minus 4. So it's just like negative value. There is some negative value. The numerator is a positive value divided by some negative value. Overall, it will be negative value, right?
How did you get minus? Minus 4.
So this is minus 4n square.
Yes, correct.
If I divide it by n square.
Yeah, 40 by n square.
40 by n square minus 4.
Yes.
So if I take limit separately, this 40 by n square will go to 0. And this limit n tends to infinite to the minus 4, it will be minus 4 only. It's a constant, right?
Okay.
So this is the thing. What I am doing is, instead of the denominator, I can take the limit separately, right? I am taking like this. Limit n tends to infinite 40 by n square minus limit n tends to infinite 4. So this will go to 0.
Correct.
And this will be like minus limit n tends to infinite 4. This will be 4. This will go to 4.
Yeah.
And overall, this will be like some infinity by minus 4.
Okay, got it.
Okay. Also, that is what Also, I wanted to mention this. See, that is what, if you get the intuition of the sequence. So if I increase my n, the numerator will increase, the denominator will decrease. So when n is 1, it is 40 minus 4, which is 36. When n is 2, it is 40 minus 4 into 4, 2 square, which is 4. 4 into 4 is 16. 40 minus 16 is 24. Okay. When n is 3, it is like 4 times 9, which is 36. So 40 minus 36 is 4. Okay. So again, when n is 4, what happens? 16, 4, 64. 40 minus 64, it will go to negative value, minus 24. Okay, you see, the denominator, as n tends to infinite, the denominator value decreases and it will approach to minus infinite, and the numerator slowly increases and approaches to plus infinite. Okay, this is what happens slowly. And when you divide it, what happens is, when you do the division, the amount that numerator increases is cubical compared to the amount that this decreases. Okay, so after a few terms, what happens is the sequence might look like some 1 lakh in the numerator and denominator is somewhere around minus 5,000, something like this. And after few other terms, it will be like 10 power some 10 power 10, and denominator may go to somewhat minus 10 power 3 or something. Sorry, minus 10 power some 7 or something. Okay, so what happens is the rate in which the denominator is decreasing is of power 2, order 2, but the rate in which the numerator is increasing is of order 3. So the numerator will take more values or higher values within for smaller values of n only. So as n increases, the numerator will dominate the denominator. Okay, that's what I wanted to convey. Once it dominates, the numerator, whatever numerator takes, the denominator will follow. Okay, so slowly what happens is, this value will go to minus infinite. Slowly it will go to minus infinite. Okay, got it?
Yes.
Next is 3.3. You said, which of the following sequences diverges to infinite? Right? Did you ask this? Which of the
no?
3.7
3, yes.
Sequences diverges to plus infinite. So these are the sequences. So now I want input from the other fellow mates in the session.
Maybe you can discuss the fourth one. Maybe this one we can see.
Fourth one, huh?
Yes,
Okay.
yes.
So first one also I wanted to mention. This is the one sequence, and maybe option 4 I will take directly, which is n plus 1 whole square minus n square. This is option 4.
Question number 4 I'm talking.
Oh, you don't want question 3, is it?
Yeah, question 3 we will work it out.
Okay, if you can work it out, it's good. Okay, anyway, I'll just comment on these things. As I have written, I have made some effort to write it down. Right?
Okay.
Okay, now people in the session, I want which of these two sequences will diverge to plus infinite. Oh, time is up already. Sorry. Okay, maybe I will discuss this. So I can simplify this sequence further. The numerator looks like n minus 1 whole square, right? N minus 1 whole square divided by n minus 1. And this you can cancel it out, and the sequence will cut down to n minus 1. So this sequence is same as this sequence. And if you see now, then the sequence is just if you start from n is equals to 1, it will be like 0, 1, 2, 3, like this. The sequence is like this, and eventually this will go to infinite, plus infinite. So this is
Yeah. So
this sequence is diverges to infinite.
by seeing you have taken n minus 1 squared, but what we gone is we gone by n squared by n squared, so we got 0 by 0, so that's why it got confused.
Okay. So even though you go in that way, as
way,
just now I discussed, right? The dominance effect.
Okay.
The numerator is n square.
Yes.
N square will dominate n.
Correct. You got it.
Slowly it will go to infinite. Okay. And the next thing also you can simplify this. N plus 1 whole square is n square plus 2n plus 1 minus n square. So this and this will get cancelled out, and this sequence can be cut down to, or can be written in another this way, 2n plus 1. Again, this sequence is also, if you see, as n tends to infinite, this will diverge to plus, right? So both are correct. Both are the sequences which diverges to plus infinite. And question number 4, I'll just comment on question number 4, and then we can end this session. So determine the range of values for k for which the sequence, so this is the sequence, 100n minus n power k divided by n power 4 minus 4n square. Now this sequence should diverge to minus infinite. Okay. So when can this diverge to minus infinite? The numerator should dominate the denominator, and also it should go, the sequence should go on the negative side, onto the negative side. Correct? That is when this sequence will diverge to minus infinite. So what I meant is the numerator should be dominant divided by this. So if the numerator is dominant, then the sequence either goes to plus infinite or minus infinite. Dominant, I mean higher powers. Higher powers than the denominator. Okay. So if numerator has higher powers than the denominator, then the sequence either goes to plus infinite or minus infinite. This is one case. And the other case is if denominator is dominant. Again, it's like higher powers than the numerator. This is the numerator. Denominator. Then whichever direction it goes, as the denominator is dominant, this will go to 0.
Sir, if we divide by n power 4, denominator and numerator.
You divide by n power 4. That is how you should start. So we have, I want the limit n tends to infinite. This 100 minus n power k divided by n power 4 minus
100n.
100n. Okay. N power 4 minus 4n square. So 100. So if you divide by n power 4, this will be limit n tends to infinite 100 by n cube minus n power k by n cube n power 4 divided by 1 minus 4 by n square. Is this correct? Am I correct?
Yes, sir.
So now you see, what can I observe from here? If I take the limits, this will become 0 minus n power. This is limit n tends to infinite. N power k minus 4. So this is 0. What I meant is this will go to 0. 1 by 1 minus 0, which is 1. Okay. Now, for what values of k, this whole thing will diverge to minus infinite. So if this wants to diverge to minus infinite, if I remove minus and minus, what I want basically, I want, if this is happening, tends to infinite, then this minus of this will tend to minus infinite. So instead of this, if I can say this is true, then that is true, correct? And now you see, n power something is there, and if n tends to infinite, this I want to be infinite. Now let me take let me start taking k values to be 0. Start with 0. Some trail and error. Let's do trail and error. Okay. So if it is 0, what happens? Limit n tends to infinite, n power minus 4. So n power minus 4, I can also write it as 1 by n power 4. Where will this go?
0.
This will go to 0. But I want this to go to plus infinite. So that means k is equals to 0 is not a the required solution for me. So maybe I will take k is equals
They
to 2.
want to go to minus infinity, not plus infinite.
I know. See, we got minus of, there is some minus here, right?
Yes.
If it is minus of limit n tends to infinite n power k minus 4 to should go to minus infinite.
Yes.
So if I can say this, if this goes to infinite, then minus of this will go to minus infinite.
Okay.
Right? That's how it is, right? If I am going towards plus infinite, and if I suddenly put minus in front of that numbers, all the numbers will be going to minus infinite, right?
Correct.
So that is what I wanted. So when k is 2, what will I get? N tends to infinite. I'm going to get n power minus 2, which is 1 by n square. Where will this go?
0.
This will also go to 0. So this is also not correct then. So now observe, if I take any k value, maybe k is equals to 4. K is equals to 4. So if k is equals to 4, what happens? Limit n tends to infinite. This will be n power 0, which will be 1. This will become n power 0. 4 minus 4, n power 0, which will become 1, and this will go to 1. So, but where should my limit should go? What it should go to infinite. So this is also not correct. So k is equals to 4 is also not a good. Right. Now if I take k as,
sir, any value greater than 4 would go to infinity, I guess, sir.
Correct. So that observation comes from here. When k is equals to 5, I'm going to get n tends to infinite, n power 5 minus 4, which is n. So when n tends to infinite, what happens to n? It will go to infinite. Right. So similarly, k is equals to 10 or anything. This will go to n tends to infinite, n power 10 minus 4, which is n power 6. And here this also, n tends to infinite, n power 10, n power 6 will go to infinite. So that is what I want. So any k you pick greater than 4, then what happens to this? Limit n tends to infinite, n power k minus 4.
Always be infinity.
This will go to infinite. So if this is true, then can I say minus limit n tends to infinite, n power k minus 4 will tend to minus infinite?
Yes, sir, in the same range of k, greater than 4.
So that means my k should be greater than 4 in order to have this particular sequence diverging to minus infinite. Okay. Okay. So yeah, so I have done problems very elaboratively because to give you some sense how.
Sir, I have a doubt.
Hmm.
Sir, one question. A1 is equal to 1 and A1 plus 1 is equal to AN upon N plus 1.
A1 is equals to 1 and
A1 is equal to 1, AN plus 1 is equal to AN upon N plus 1.
What happens to this?
So, sir, how to find it is non-decreasing and non-increasing sequence? How to find?
Okay. So that is what I said there. You just get the intuition of this sequence. The first term is 1. What will be the second term? One by 2. So this is like just substitute n is equals to 1. You will get A2 is equals to A1 by 2. A1 is 1. And so if it is 1 by 2 is 1 half. What will happen to the third term? A3. So A3 is
2 by
A2 by
3.
2 plus 1. No, it's not 2 by 3. It is A2 by 3. What is A2? It is half. So that will give you half by 3, which is 1 by 6. Okay. And what happens to the next term? A4 is A3 by 3 plus 1. So A3 is 1 by 6. 1 by 6 by 4. 1 by 24. And what happens to the next term? Next term is A4 by 4 plus 1. So A4 itself is 1 by 24 divided by 5. 1 by 120. So and so on. So if you see that, just see the sequence, it started from 1, then it went to half, it became 1 by 6 in the third term. The third term is 1 by 6, 1 by 24, 1 by 120, 1 by 120, and the next term is 1 by 6 factorial. And the next term will be 1 by 7 factorial and so on. Okay. So where is this approaching? Where is this going slowly?
0. To 0. 0, sir.
And also is the sequence increasing or decreasing?
Decreasing.
Decreasing sequence. Yeah. Is this a convergent sequence or divergent sequence?
Convergence.
Convergent.
So what is the upper bound for this sequence?
1.
And what is the lower bound for this?
0.
0.
Is this sequence bounded sequence?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So that is it. That is how you can do. Okay. So yeah, with that note, we will end today's session here. Thanks for joining. I hope you got some intuitions about how to go with week 3 contents. So use these intuitions. And next week we are going to have revision sessions planned. We will add it to the calendar in short time. So we will do week 4 and then we will do the revision sessions also. We will do week 1 and week 2 in one session and week 3 and week 4 in another session. So you will be getting some 2 revision sessions. And then we will, in that revision sessions, we will give you much more tips, tricks and shortcuts, how to attack the problems. Okay.
By seeing the numerator and denominator powers, we should able to judge, right? So I think we need some tips on that. Maybe next session you can give that.
Sure. In revision sessions, again, revision sessions are slightly inclined towards the qualifier preparation. So this will not be like the whole, we will not cover whole contents and all. Whatever we are going to cover will be slightly inclined to the qualifier syllabus. Okay. So qualifier question paper. Okay. So that will give you some more insights of how to prepare for qualifier also. Okay.
It is moderate difficulty or
no?
What is?
No. See, as I already told,
Okay.
the qualifier paper will be a mix-up of activity questions, practice assignment questions, and graded assignment questions, and one or two, at most two, new kind of questions, not the difficult questions.
Okay.
So you might not have seen it in graded or practice or activity anywhere, but it will be easy only. Once you understand the concept, you can able to do that.
Okay.
Okay. Yeah.
Thank you.
Okay, guys. Then thank you so much for joining and have a
Hello.
great day.
Hello.
Thank you, sir.
Thank you.
Thanks.
Hello.
Yes.
Is this session recorded?
Yes. It is recorded and yeah,
Not
this is the
streamed
link.
there. Can you share the link?
Link I just pasted in the chat. You can take it. Or in the calendar, I will just upload it, update it now.
Yeah, please. Yeah, record in the calendar there. And one more request there. We have only 2 sessions for the math there every week there only.
Right.
Yeah. Others having that more sessions there.
Yeah. See, we are trying to get a few other instructors
Because,
also.
Yeah.
Yes,
For the week 1 and week 2 maths, it's up to the we can understand it there. Mac week onwards, week 3 and 4, they may be difficulty increasing in the all that thing. So it will be better have a little more